Okay, in this video, we're going to be looking at equations in a Cartesian coordinate system. And in this video, we're going to be talking about the equations of vertical and horizontal lines, equations of lines, systems of linear equations, substitution method, elimination method, also solutions to various systems of linear equations, and fitting a line to data. We'll first talk about what the Cartesian coordinate system is and what it looks like. The Cartesian coordinate system enables us to study both geometry and algebra simultaneously. And the Cartesian coordinate system is constructed by placing two number lines perpendicular to each other. So what you're going to see here is a Cartesian coordinate system that looks like this. You have two number lines that are perpendicular to each other. You have a horizontal axis that goes straight across and a vertical axis that goes straight up and down. The horizontal axis is called the x-axis. The y-axis is going to be our vertical axis that goes straight up and down. Now, we can also call this the Cartesian coordinate plane because what the x-axis and the y-axis does, it separates the plane into four different sections. And those sections are called quadrants. So in the upper right-hand corner, we call that quadrant 1. In the upper left-hand corner is quadrant 2. In the lower left-hand corner is quadrant 3. And the lower right-hand corner is quadrant 4. Now the x-axis and the y-axis intersect at a point. That point of intersection is called the origin, and is usually the ordered pair 0, 0. So in quadrant 1, each ordered pair has like two numbers. The first number is the x-coordinate, and the second number is the y-coordinate. So in quadrant 1, your x-coordinate and y-coordinate are positive. In the second quadrant, your x-coordinate is negative, and the y-coordinate is positive. In the third quadrant, both the x and the y-coordinates are negative, whereas in quadrant 4, your x-coordinate is positive and your y-coordinate is negative. Okay? Now, when we plot points, we first start at the origin and then we look at the first number, which is your x-coordinate. The sign of the x-coordinate will tell you to move either to the left or to the right. If it's positive, you move to the right. If the x-coordinate is negative, you move to the left. And then the y, your second number, is either going to be positive or negative. If it's positive, then you'll move up. Or if it's negative, you're going to move down. So the y-coordinate tells you to move either up or down from your x. Like in this ordered pair, 3, 4. You start at the origin. You're going to go to the right 3 places because it's positive 3 and up 4. And draw the point. Also for 3, negative 4, 3 is positive, so you start at 0, 0. You go to the right 3 places, and then you're going to go down 4 places because your y-coordinate is negative. And then draw the point. Okay, so that's just the idea of how you plot points on a coordinate system. The location of any point P can be described by an ordered pair of numbers, which is a comma b, where a perpendicular from P to the x-axis intersects at a point with coordinate A, and a perpendicular from P to the y-axis intersects at a point with coordinate B, and that point is identified as P with the ordered pairs with the coordinates A, comma B. Usually an ordered pair will have a letter in front of it. That would be just like point P with the coordinates A, comma B. Like for example, let's say A with the coordinates 3, 4. Because you'll go to the right 3 and then up 4 and draw the point, and then you'll label that point as point A with a capital letter. We'll look at equations of vertical and horizontal lines. Every point on the x-axis has a y-coordinate of 0. Thus, the x-axis can be described as the set of all points x comma y such that y is equal to 0. So the x-axis will have the equation y is equal to 0 because that y-coordinate is going to be 0. So in this case here, let's say I draw the x and the y-axis of our Cartesian coordinate plane. Now, each point on the x-axis has the y-coordinate of 0 because you're either going to go to the left or to the right on the x-axis. But since y is 0, you're not going to move up or down, so that point will be on the x-axis. So these points that I've drawn have a y-coordinate of 0. So we can consider the x-axis having the equation y is equal to 0. And every point on the y-axis has an x-coordinate of 0. That means that the y-axis can be described as a set of all points x comma y such that x is equal to 0. And y can be any arbitrary real number. So the y-axis will have the equation x is equal to 0. So think of this as the y-axis here. Each point on here has the y-coordinate of 0. Because the point is on the y-axis, okay? So x is 0, meaning you're not going to move to the left or to the right. So here, you move up or down. So your x-coordinate is always going to be 0. So that's why this y-axis will have the equation x equals 0. Let's look at sketching the graph of each of the following. Like A has x is equal to 2. Now, I'm going to use a XY table to show you how this is going to be done. So to graph x equals 2, I can assign y as any arbitrary value, but my x is equal to 2, so that means the x-coordinate that I choose to graph this must be equal to 2. The y can be anything I want to. Here, for this 2, this y could be 0. For this 2, the y could be 1. And for this 2, the y can be 2. And then I simply plot those points. 2, 0 is the first order pair, so I go to the right 2. And it's on the x-axis, so we'll draw that point. 2, 1 means go to the right 2 and up 1. Draw the point. 2, 2 means go to the right 2 and up 2. And draw the point. And as you can see, those 3 points form a vertical line. And that's the graph of the vertical line with the equation x is equal to 2. Now part B, you got y is equal to 3. Now if I use an xy table here, regardless of what x value that I choose, my y must be equal to 3. So the y-coordinate must be equal to 3 because of the equation y is equal to 3. And I can use any value for x, like 0, let's say 1, even 3. So for the 0, 3, you stay at 0, but you're going to go up 3 and draw the point. For 1, 3, you're going to go to the right 1 and up 3 and draw the point. And then for 3, 3, you're going to go to the right 3 and up 3 and draw the point. So those 3 points form the horizontal line, which is going to be the equation y is equal to 3. Okay? So keep in mind that x equal to a real number means that you're going to have a vertical line. Y equal to a real number means you're going to have a horizontal line. Okay. Now here's another one. X is less than 2 and y is equal to 3. Okay, so here this is the intersection of those two. Now if I use an XY table, I know my y value has to be equal to 3 because it says y is equal to 3. Now x is less than 2 means values of x that are less than 2. So I have to pick x values that are less than 2, like let's say 1 or 0, or I can say -1. Those values are less than 2. But I'm also going to put 2 here because I want to know where the ordered pair is at x equals 2. Well, it's going to be 2, 3 because of the fact that y is equal to 3. Now, when you go to the right 2 and up 3, notice that there is an empty circle at 2, 3. So we have to draw an empty circle to show that that ordered pair will not be included in this particular situation here. And then you can plot the remaining points like 1, 3, go to the right 1 and up 3. Stay at 0 for 0, 3, stay at 0, go up 3, and then for -1, and I'll just go ahead and put a -1 over here. You go to the left 1 and up 3. And you can see that the graph is going to look like this, where you have an empty circle at the coordinate 2, 3. Okay, so that's how you'll graph that particular intersection of two different, of an inequality and an equation. Let's look at the equations of vertical and horizontal lines still. In general, the graph of the equation x is equal to a, where a is some real number, is the line perpendicular to the x-axis through the point with coordinates a, 0. And I've already talked about this a little bit earlier, so I'll bring it up again. Okay, it's going to be perpendicular to the x-axis, so here's the x-axis here. And the graph of that line, let's say this is A, the line passing through A, or the vertical line passing through A, and it's perpendicular to the x-axis. That's the graph of the equation x is equal to A. And similarly, the graph of the equation y is equal to B is the line perpendicular to the y-axis through the point with coordinate 0, B. Okay, so here's 0, B up here. If we draw a line through that point and it's perpendicular to the y-axis, that's going to be your equation, y is equal to B. So again, y equaling to a non-zero number is going to be a horizontal line, and x equal to some real number means that the line is going to be vertical. Okay, all points corresponding to arithmetic sequences lie along lines. Okay, now in this case here, this red line in the middle that I'm tracing here represents the equation y is equal to x. That means if x is 1, y is equal to 1, x is 2, y is equal to 2, or if x is -1, y is equal to -1, and so on. So whatever x is, y is going to have that same value. This one in blue is y is equal to 2x. That means you take whatever your x value is and double it. That means if x is 1, y is going to be equal to 2. If x is equal to 2, y will be equal to 4. If x is equal to 3, y is equal to 6, and so on. And then this one in green is y is equal to 1/2 x. That means you're going to take 1/2 of the x value that you assign to it. So if x is 1, y is going to be equal to 1/2 because you're taking 1/2 of 1. Or if x is 2, 1/2 of 2 will be 1. X is 4 means 1/2 of 4 will be 2, and so on. Alright, next we'll look at slope. The slope of a line, which is usually represented by m, is the measure of its steepness. Okay, so in this case here, think of a ramp where handicapped people use to get into certain buildings, because certain buildings do have ramps for handicapped people that are in wheelchairs. That ramp has what they call a slope because it has steepness. Okay, and here these are 3 different types of slopes here. If this line rises from left to right, that means that your slope is positive. That means it's greater than 0. So a line with a positive slope increases from left to right. I'm going to jump over here to this one. As you can see, this line falls from left to right. That means that the slope is negative. So a line with a negative slope decreases from left to right. And in the middle, you see a horizontal line that we talked about earlier. A horizontal line means that your slope is 0. Okay, so a line with a 0 slope is horizontal. Okay. And I also want to mention, if you have the vertical line like this, a vertical line means that your slope is undefined. A vertical line means that your slope is undefined. Okay, look at this example. Find the equation of the line that contains 0, 0, and 2, 3. Now, looking at this, one of our ordered pairs is 0, 0. Okay, so here that line passes through the origin. So that means that the equation of that line will be of the form y is equal to mx. Okay, so now using this, we're going to substitute x with the 2, and the y will be substituted with 3. So that means we're going to have 3 is equal to m times 2. Or you can write this as 3 is equal to 2 times m. And to find out what m is, you just simply divide by 2. So that means m is equal to 3 halves. So that slope there is 3 halves. And the equation, y is equal to 3 halves x, we just take this form, replace the m with the 3 halves. So that means your equation for that line that contains the point 0, 0 and 2, 3 will be y is equal to 3 halves x. For a given value of m, the graph of y is equal to mx plus b is a straight line through the point 0b and parallel to the line whose equation is y is equal to mx. Okay, so here the graph of that line y is equal to mx plus b can be obtained from the graph of y is equal to mx by just sliding y equals mx up or down b units dependent upon the value of b. So in this case, if that b was a minus b, then you'll be shifting it down. If it's a plus b, you'll shift that graph upward. Okay, so we can think of y is equal to mx plus b as the parent graph. And then y is equal to mx plus b means that there's going to be a vertical shift. That graph will be shifting vertically either up or down. And it depends upon the value of b. Like in this illustration here. Now, if you look at the one on the right where you have the y is equal to mx plus b and the y is equal to mx, here's the graph of y is equal to mx. It looks like this. The plus b means that you're shifting it upward, or it could be shifted downward, and it depends upon the value of b. And another example would be that y is equal to x equals to x. Let's say that's the parent graph. And then you got y is equal to x plus 2. It's the same as y is equal to x, but it's just shifted up 2 places. And for y is equal to x minus 2, it's the same as y is equal to x, but it's just shifted down 2 places. Okay. And also they mention any two parallel lines have the same slope, or are vertical lines with no slope. And I don't like to use the word no slope. I like to use undefined slope. Okay. The graph of y is equal to mx plus b crosses the y-axis at the point P, which is the ordered pair 0b. And the value of y at the point of intersection of any line with the y-axis is called the y-intercept. So that y-intercept, that's the point where the graph crosses the y-axis. The slope-intercept form of a linear equation, of course, is y is equal to mx plus b. And the value of the value of x at the point of intersection of any line with the x-axis is called the x-intercept. So let me go back to this graph right here. Let's take this line right here. Here's P, which is 0B. That's your y-intercept, because that's the point where the graph crosses the y-axis. Okay? And if this line crosses the graph at the x-axis right here, this point right here, that's going to be your x-intercept. Because that's the point where the graph crosses the x-axis. Okay, so it's two different points here. We can call this here A0 and label this as, let's say, probably Q. You can use any letter if you want. So keep in mind, the x-intercept and the y-intercept are two separate points. The y-intercept is the point where the graph crosses the y-axis. The x-intercept is the point where the graph crosses the x-axis. Look at this example here. Given the equation y minus 3x is equal to negative 6, find the slope, the y-intercept, and the x-intercept, and then graph the line. Okay, with this one, you got y minus 3x equals negative 6. Let's write this in slope-intercept form, which means you want to get y by itself. And to do that, you'll have to add 3x on both sides of the equation. So to get that, you're going to have y is equal to, this will be 3x minus 6. That's your equation in slope-intercept form. Okay? Because it is of the form y is equal to mx plus b. M is the slope. That's the number in front of the x. So the slope there will be 3. The b, which is your y-intercept, that's the number added to or subtracted from 3x. So that's negative 6. So the y-intercept is negative 6. Okay. So we got the slope, we got the y-intercept. Now we need the x-intercept. We're going to substitute. To find the x-intercept, you take your y and replace it with 0. So you're going to substitute 0 for y in this equation. And I'm going to write it out here. Y is equal to 3x minus 6. Substitute the y with 0. So you have 0 is equal to 3x minus 6. And then to get the x by itself, you're going to add 6 to both sides. So we're just simply solving for x here. So you have 3x is equal to 6. Then divide by 3. You're going to get x is equal to 2. So that means that your x-intercept will be 2, meaning that the graph of this linear equation will be crossing the x-axis at 2. Okay, so on the next sheet, you're going to see here, you have your y-intercept, which is 0, negative 6, and the x-intercept, which is 2, 0. Those 2 points lie on the line, so you'll just plot those points. So for 0, negative 6, you'll stay at 0, but you'll go down to 6, and draw the point. And then 2, 0, you go to the right 2, and you'll stay on the x-axis and draw the point. So all you need is just 2 points to construct the graph of the linear equation. Y minus 3x is equal to 6, negative 6. Okay, every line has an equation of the form of either y is equal to mx plus b or x is equal to a, where m is the slope and b is the y-intercept. And any equation that can be put in one of those forms is called a linear equation. Okay, because a linear equation is nothing but an equation that can be, where the graph will be nothing but a straight line. All right, next we're going to look at how to determine the slope of any line passing through 2 points. In this case here, you're given 2 points, A, which is x1, y1, and I'm going to say this is B, which is x2, y2, with x1 not equaling to x2. So the slope, which is your lowercase m of the line AB, is going to be this particular formula. M, which is equal to y2 minus y1, divided by x2 minus x1. Okay, the y2 minus y1 is considered to be the rise or the change in y. x2 minus x1, that's the run. That's the change in x. So it's always a change in y divided by the change in x, which is called the rise divided by the run. A couple of examples of finding the slope of a line would be this. Let's say we're given the points A with the ordered pair 3, 1 and B with the ordered pair 5, 4. You want to find the slope of the line segment AB. Now in both of these we're using the formula m is equal to y2 minus y1 divided by x2 minus x1. So in this case here, for A, which is 3, 1, x1 will be 3, y1 will be 1. For B, with the ordered pair 5, 4, x2 is going to be 5, and y2 will be 4. So to find the slope, we do y2 minus y1, that's 4 minus 1, which is this, and then divided by x2 minus x1, 5 minus 3, that's this right here. Numerator 4 minus 1, that's 3. Denominator 5 minus 3 is 2. So the slope there will be 3 over 2. And usually we'll leave that as an improper fraction. Part B is finding the slope of the line passing through A, which is negative 3, 4, and B with the coordinates negative 1, 0. Now in this case here, you can let your coordinates for B be x1, y1. x1 will be negative 1, y1 will be 0. And then for A, negative 3, 4. x2 is negative 3, y2 will be 4. Okay, but the formula is still the same. y2 minus y1 divided by x2 minus x1. So in this case here, this will be 4 minus 0. y2 minus y1 divided by x2, which is negative 3, minus x1, which is negative 1. The numerator, you have 4 minus 0, that's 4. The denominator, negative 3 minus a negative 1, is the same as saying negative 3 plus 1, that's negative 2. So now you have 4 divided by negative 2, which is negative 2. So the slope of that line passing through those 2 points would be negative 2. Okay, another example would be the points negative 4, 0, and 1, 4 are on line L. We want to find the slope of the line and the equation of the line. In this case here, we're going to do this. This is going to be x1, y1 for negative 4, 0, respectively, and this will be x2, y2 for 1, 4, respectively. So the slope formula will be y2 minus y1, which is 4 minus 0, divided by x2 minus x1, 1 minus a negative 4. 4 minus 0 is 4, divided by 1 minus a negative 4, or 1 plus 4, which will be 5. So the slope will be simply 4/5. Now to find the equation of the line, now there are ways that you can do this. You can use y is equal to mx plus b and use either one of these 2 points. I'm going to use the negative 4, 0 because that y coordinate is 0. And I'll replace the y with 0 and the x with negative 4. So here y is 0, so that's going to be 0 is equal to, my slope was 4/5, so that's going to be 4/5 times x, which is negative 4, plus b. Because I want to find out what b is, which is the y-intercept. I know what the slope is. Okay, so now I have 0 is equal to 4/5 times negative 4 over 1. That's going to be negative 16/5, then plus b. Now to find out what b is, well, I got minus 16/5, so I'll add 16/5 to both sides. So that means that b must be equal to 16/5. Now I know what the y-intercept is. I already know what the slope is, so we'll just replace those 2 values in our slope-intercept form. Y is equal to mx plus b. So now you have y is equal to m, which is your slope, that's 4/5 x plus 16/5. okay, which is exactly what they have here. Okay, next we'll look at systems of linear equations. The mathematical descriptions of many problems involve more than one equation, each having more than one unknown. To solve such problems, we must find a common solution to the equations, if it exists. Look at this example here. Mei Chen paid $18 for 3 soy burgers and 12 orders of fries. Another time she paid $12 for 4 soy burgers and 4 orders of fries. Assume the prices have not changed. Set up a system of equations with two unknowns, representing the prices of a soy burger and an order of fries, respectively. Okay, now this is one of those word problems where you just have to translate them into two equations or a system of equations and then try to solve it. Here's the procedure. You're going to let X be the price in dollars of a soy burger and Y be the price of an order of fries. 3 soy burgers cost $3x because we're letting X be the cost of a soy burger. So 3 soy burgers will be 3 times X. 12 orders of fries, we let Y be the price of the order of fries, so it's 12 times Y. Now, one order May paid $18, so that equation is going to be this: 3x plus 12y equaling to 18. Or, if you were to divide each and every term in this equation by 3, you'll get this equation: x plus 4y is equal to 6. That's equivalent to this one. Alright, because May paid $12 for the order, we have this: 4x plus 4y is equal to 12. Or you can do this: divide each and every term by 4 in this equation. You'll get a simpler equation: x plus y is equal to 3. Now notice that they graph these two lines on the coordinate plane. And when they graph these, the point of intersection is at this ordered pair, 2, 1. So here the lines intersecting at 2, 1. Here x is 2, y is equal to 1. X is going to be the cost of a soy burger, so the cost of that soy burger is $2. 1 is your y. We let y be the cost of the fries, so the fries had to cost $1. Now keep in mind, this is not the only way that you can solve a system of equations here. There are other methods that you can use, because if you were to graph this, you might not get an accurate point of intersection. So another method would be the substitution method of solving a system of equations. And here's the procedure for doing that. Number 1, you're going to solve one of the equations for one of the variables, either the x or the y, for instance. Then step 2, substitute this for the same variable in the other equation. Then the third step, solve the resulting equation. And then you're going to substitute the result back into step 1 to find the other variable. Then check the solutions if required, and then you're going to write the solution. Let's say we want to solve this system here. 3x minus 4y is equal to 5, and 2x plus 5y is equal to 1. Okay? The first thing we'll do is rewrite one of the equations expressing y in terms of x. So here, they took the first equation: 3x minus 4y is equal to 5. And then they solve for y. To do that, you have to subtract 3x on both sides, which means you're going to have negative 4y that's equal to, I'm just rewriting this with the x first, negative 3x plus 5. And then to get the y by itself, you'll divide each and every term by negative 4, which means you're going to have y is equal to, this will just be positive 3/4 x. And then this will be just negative 5/4, because positive divided by that negative will make that a minus sign. So now you have y is equal to negative 3/4 x minus 5/4. Or you can write that as y is equal to 3x minus 5 all over 4, because the common denominator is 4, which is what they have here. Okay, now the next thing we're going to do here is equate the expressions for y and solve the resulting equation for x. We're going to take that second equation, which is 2x plus 5y is equal to 1. Replace the y with the 3x minus 5 all over 4. So now you get 2 times 2x plus 5 times the quantity 3x minus 5 divided by 4 equal to 1. Okay, now the next step, since we got that 4 in the denominator, what they did here is multiply both sides of the equation by 4. Okay, so on the left side, you got to use the distributive property, multiply the 4 times that 2x, that would give you 8x. And then you got 4 times this expression, 5 times the quantity 3x minus 5 all over 4. Notice that the 4's will divide out. You're going to be left with just this, 5 times the quantity 3x minus 5. So now you got 8x plus 5 times parentheses 3x minus 5 equals to 4. Then you use the distributive property here, bring over the 8x, and then you're going to do 5 times 3x, that's 15x, and then 5 times minus 5, that's minus 25. So now you got 8x plus 15x minus 25 is equal to 4. Now, they combine like terms here, 8x and 15x is 23x, and then they move the minus 25 over to where the 4 is, and made that a plus 25. Or you can think of this as adding 25 to both sides. So 4 plus 25 is 29, so now 23x equals 29. Divide both sides by 23, you're going to get x is equal to 29 over 23. So that's what the x value is for this equation. X equals 29 23rds. Now we want to find out what y is. And you're going to do that by substituting 29 over 23 into y is equal to 3x minus 5 all over 4. And then you're going to find out what y is. So here you got 3 times 29 over 23 minus 5 all over 4. And it would be easier if I did this to show you how it's done. Okay, now that numerator, multiply 3 over 1 times 29 over 23. You're going to get 87 over 23. Minus. Now for 5 over 1, the common denominator is 23. If I multiply 5 times 23, I'm going to get 100, help me out, 115 all over 4. And then subtract 87 23rds minus 115 over 23. You're going to get a negative 28 23rds. And then that's going to be multiplied by the reciprocal of 4 over 1, which is 1/4. And then 4 goes into negative 28 negative 7 times. So now you're going to see this is going to be negative 7 23rds. Okay, so that's what y is equal to, negative 7 over 23. So the solution for that system will be 29 23rds and negative 7 23rds. Okay. Another method of solving a system of linear equations would be the elimination method. Now what you want to do here is write both equations in standard form. And standard form for a linear equation is always ax plus by is equal to c. Here the x and the y are on one side of the equation. The numerical terms are on the other side of the equation. The a, which is a number in front of the x, can't be negative. And then second, you're going to multiply both sides of each equation by a suitable real number so that one of the variables will be eliminated by addition of the equations. And then the third step, you're going to add the equations and solve the resulting equation. Now, in step number 2, you might not have to multiply by a suitable real number. You might see that you could easily add the two equations together if one is negative, if one is minus and the other one is a plus. and it's the same variable with the same coefficient. Then you're going to substitute the value found in step 3 into one of the original equations and solve this equation. Then check your solution if required and then write the solution. Let's look at this one right here. You got 3x plus 2y is equal to 5, and then 5x minus 4y is equal to 3. Okay, now we can't eliminate a y by just simply adding those two equations together. So that means we need to multiply by a suitable number in order to eliminate the variable. Let's eliminate the y, because I see I got a plus 2y and a minus 4y. One is plus and the other one is negative. So here, if I want to make this a 4y, the first equation of 4y, I need to multiply that top equation by 2. So that means that 2 times 3y will give me the 6x. 2 times 3x, that's 6x. 2 times 2y would be a plus 4y. That's equal to 5 times 2, that'll be 10. Then bring down this. 5x minus 4y is equal to 3. Now you can see negative. I have a plus 4y and a minus 4y. That can be eliminated through addition. Okay, so here I'll add the equations and then solve for x. So here 6x and 5x is 11x. Plus 4y and the minus 4y, those terms are gone. That's equal to 10 plus 3, that's 13. So now you got 11x is equal to 13. Then divide both sides by 11, you're going to get x is equal to 13 elevenths. So the x value is 13 elevenths. So now we need to find out what y is. We're going to substitute 13 elevenths for x in either of the original equations, and then we're going to solve for y. So we take the equation 3x plus 2y is equal to 5, and just replace the x with 13 elevenths. So now you got 3 times 13 over 11 plus 2y is equal to 5. And then you're going to say 3 times 13 over 11, or 3 over 1 times 13 over 11 will be 39 elevenths, plus 2y is equal to 5. Okay, so now, to get 2y by itself, you'll have to do 5 minus 39 elevenths. Okay, so now we have to change 5 with the common denominator of 11, which means we have to multiply 5 times 11, which will be 55, minus 39 elevenths. And if you subtract that, you're going to get 16 over 11. So now this is where they got the 2y is equal to 16 over 11 from. Then divide by 2, or an easy way, the reciprocal of 2 is 1/2. Multiply both sides by 1/2, which will give you 16 over 22. If you multiply numerator times numerator, denominator times denominator, that would be 16 over 22, but you'll reduce that to 8 elevenths. So that solution there will be 13 elevenths and 8 elevenths as your ordered pair. Okay. We'll talk about solutions to the systems of linear equations. Geometrically, a system of two linear equations can be characterized as follows. Number 1, the system has a unique solution if and only if the graphs of the equations intersect in a single point. Number 2, the solution has no solution if and only if the equations represent parallel lines. And 3, the system has infinitely many solutions if and only if the equations represent the same line. So with a unique solution, the graph will the graphs of the two lines intersect at a single point. If it's no solution, that means you're going to have parallel lines. They're not going to intersect at a point. Infinitely many solutions means that the two equations represent the same line. Okay, let's look at this situation here. We want to identify the system as having a unique solution, no solution, or infinitely many solutions. Here we got 2x minus 3y is equal to 5, and 1/2 x minus y is equal to 1. Now, what they did was write each equation in slope-intercept form. So I'm going to start off with the 2x minus 3y is equal to 5. Now, to write an equation in slope-intercept form, you want to get the y by itself. So that means you want to subtract 2x on both sides. which means you're going to have negative 3y equal to negative 2x plus 5. And then to get the y by itself, you'll divide each and every term by negative 3, which means you're going to have y is equal to, well, a negative and a negative is a positive, so that's going to be 2/3 x. A positive and a negative, that's going to be a minus 5/3. Okay, so that's where they got the 2/3 x minus 5/3. And then the other one, 1/2 x minus y is equal to 1. To get that y by itself, let's subtract 1/2 x on both sides. So now you got negative y is equal to negative 1/2 x plus 1. And then we're going to divide each and every term by negative 1. We want to get rid of that negative sign that's in front of it. So that means you got y is equal to positive 1/2 x minus 1. Okay, so that's where they got this. Now let's look at the slopes here. They're both in slope-intercept form, so here the slope is the number in front of the x. That's 2/3. And in the second equation, y is equal to 1/2 x plus 1, the slope is 1/2. Notice that these two slopes are different, which means there is a unique solution, meaning that the graph of those two lines will intersect at a single point. Okay, another example would be this. X over 3 minus y over 4 is equal to 1, and 3y minus 4x plus 12 equal to 0. Okay, we can write each equation in slope-intercept form, which is what I will do. For this first equation, we got x over 3 minus y over 4 is equal to 1. Now, in this case here, the common denominator of 3 and 4 is 12. So it will be much easier to multiply each and every term in that equation by 12. So now 3 goes into 12 4 times, so now that's 4x, minus 4 goes into 12 3 times, so now you got 4x minus 3y is equal to 12 times 1, which is 12. Okay. Now, we want to get y by itself. Let's subtract 4x on both sides. So now you got negative 3y is equal to negative 4x plus 12. And then divide both sides by negative 3. We'll divide each and every term by negative 3. So now you got y is equal to positive 4/3 x minus 4. So that's your equation in slope-intercept form. Okay, the second equation, 3y minus 4x plus 12 equal to 0. Three y minus 4x plus 12 is equal to 0. Let me see if I copied that correctly. Yes. We want to get this 3y by itself. I'm going to do this. Add 4x to both sides. Not only that, I'm going to move the 12 over to the opposite side by subtracting 12. So now we got 3y is equal to 4x minus 12. And then you want to divide each and every term by 3. You're going to get y is equal to 4/3 x minus 4. Notice that these two equations are exactly the same when I put them in slope-intercept form. So that means that those two original equations that were written in two different forms here represent the same line. So this system will have infinitely many solutions. Alright, now look at this one. 6x minus 9y is equal to 5, and negative 8x plus 12y is equal to 7. Okay, now let's write this in slope-intercept form as well. Alright, in this case here we got 6x minus 9y is equal to 5. We'll start with that one. We want to get the y by itself, so we need to subtract 6x on both sides. So now you get negative 9y is equal to negative 6x plus 5. And then going to divide each and every term by negative 9. So now you got y is equal to, now negative 6/9, if you reduce that, it'll negative 6 over negative 9, if you reduce that, it'll be 2/3. So it'll be 2/3 x minus 5/9. Okay. Now the other equation, negative 8x plus 12y equals 7. Okay. Now to get the y by itself, you're going to add 8x to both sides. That means 12y is equal to 8x plus 7. And then to get the y by itself, you'll divide both sides by 12. And I'm dividing each and every term by 12. So now you got y is equal to 8/12 reduces to 2/3. So now it's 2/3 x plus 7/12. Now, in this case, your slope is 2/3 for the first equation. The second equation also has a slope of 2/3. But your y-intercepts are different. So here, you have the same slope but different y-intercepts. So this system has no solution. Okay. That means that the lines are going to be parallel when you graph those on the coordinate plane. Last, we'll talk about fitting a line to data. There's often a relationship between two variables. When the data are graphed, there may not be a single line that goes through all of the points, but the points may appear to approximate or follow a straight line. In such cases, it is useful to find the equation of what seems to be the trend line. Knowing the equation of such a line enables us to predict an outcome without actually performing the experiment. Okay. And the following is nothing but a graphical approach to find the trend line. What you want to do here is choose a line that seems to follow the given points so that there are about an equal number of points below the line as above the line. Number 2, you want to determine two convenient points on the line and approximate the x and y coordinates of these points. And use the points in number 2 to determine the equation of the line. Okay, in this example, you have a shirt manufacturer. Notice that the number of units sold depends upon the price charged. Find the equation of the line that seems to fit the data best. Then use the equation to predict the number of units that will be sold if the price per unit is $60. So here we have the price per unit, and then the number of units sold. Excuse me. And on this next sheet, you'll see that they plotted those points that were on that table onto this graph. And what they did was selected two convenient points, and they used the techniques discussed earlier to determine the equation of the line, which is then sketched. And they came up with the equation y is equal to negative 10x plus 700. Now keep in mind, there are technology out there that you can use, like your TI-83 or 84 graphing calculator to come up with an accurate graph of the linear equation that would best fit this situation with those points that are given. And sometimes when points are not in a perfect straight line, this kind of graph in this case is called a scatter plot, because you have points that are scattered in a way that can be scattered either upward or downward, or just all over the place. Now you're going to use that equation y is equal to negative 10x plus 700 to substitute x for 60 in that equation. So now you have y is equal to negative 10 times 60 plus 700. Now, negative 10 times 60 is negative 600, plus the 700 will give you y is equal to 100. So we can predict that 100,000 units will be sold if the price per unit is $60. Okay, so that's how they use the scatter plot, as it is called, and we'll talk about that in another course for coming up with the line that best fits the data and then make the predictions for that data. And that will conclude this particular video on equations in the Cartesian coordinate system.